In this section, we're going to look at various signs of trigonometric functions in the four quadrants. And we probably remember that we have this definitions such as sine equals y over r for the circular definition. Another one that we can think of is that the cosine of theta is going to be equal to x over r. And the third one that we should keep in mind is tangent of theta equals y over x. Now, what we're doing with these is we're considering that the signs of x and y in all the quadrants. No matter what, r is going to be greater than 0. Okay, so it doesn't even matter what r is going to be for any of these. All right, so think about this. In quadrant 1, x is positive and y is positive. So that means all the trigonometric functions are positive. In quadrant 2, we know that x is negative, but y is positive. So what that means is that the only functions that are going to be positive are going to be the sine function, because it has y as positive. Every other function except for its reciprocal, which remember is going to be cosecant of theta, which would be r over y. That's also positive in quadrant 2. So again, sine of theta and cosecant of theta are positive in quadrant 2. Now in quadrant 3, both x and y are less than 0. So what that means is that anything with just an x, such as the cosine and the sine, is going to be negative, but tangent, as well as its reciprocal cotangent, because remember cotangent of theta is going to be x over y, that's going to be positive as well, since when you divide negative by negative, it's positive. All right, and then finally, the last thing we should recall is that the cosine is the x coordinate, and in quadrant number 4, x is greater than 0, but y is less than 0. All right, so that's how we can kind of remember which of the trig functions are going to be positive in which quadrants. Now, another way to remember it is an acronym. All right, and if you start in quadrant 1 and you draw the letter C, and just remember all students take calculus. Okay, so all students take calculus. What that'll do is that'll tell you one of the two trigonometric functions that are positive, at least in quadrants 2, 3, and 4. So all students take calculus. And so all in quadrant 1, sine and cosecant. Okay, so all students take calculus for cosine. All right, so if you remember those, that'll help you to remember which quadrant the functions are going to be positive. Okay, so essentially, let's take a look at some problems to where we can remember or help us to remember the signs of these trigonometric functions. So let's say that theta is an angle in standard position. Name the quadrant in which theta lies in if both the sine function and the cotangent function are greater than 0. Now, we know all students take calculus. All right, so right away, we know that the sine function is positive. And but that also means that every other function is negative. So like tangent would be negative, cosine would be negative here. And cotangent is positive, right? But that doesn't make sense because the tangent is the reciprocal of that, all right? So now in quadrant 3, we know that the tangent function is positive. So that would also mean that the cotangent of theta is greater than 0. But the sine of theta is less than 0 in quadrant 3. So it can't be that one. And it certainly can't be this one, all right? Just because we know that the sine function is less than 0 in this quadrant. So the only one it could be is quadrant 1, all right? And that makes sense because both of those are going to be positive, okay? So it will be quadrant 1 for us, right? Now, what if sine is less than 0? So here's what I do. I have my all students take calculus, okay? And right away, if sine is less than 0, it can't be quadrant 1, and it can't be quadrant number 2, all right? So the secant is greater than 0, okay? So we know that the secant has the same property as the cosine function, okay? So if secant is greater than 0, that means cos is greater than 0. And it looks like quadrant 4 meets that, okay? Because over here, we know that the sine of theta is less than 0, but we also know that the cosine of theta is greater than 0, okay, which inherently means that the secant of theta is greater than 0. So it's got to be quadrant 4. All right, so that's how you kind of try to do it. Maybe eliminate the quadrants to where the first condition is not satisfied, all right? And then, or maybe where the first condition is satisfied, which has to be either quadrant 3 or 4, and then look for the other condition, all right? Now, another type of problem that can arise from this is if we're given the value of a trigonometric function and we tell which quadrant that function terminates in. Okay, so again, all students take calculus. Okay, so we're in quadrant 2, which means that the only functions that are going to be positive are going to be the sine function as well as the cosecant function. Okay, so the cosecant of theta and the sine of theta are going to be greater than 0 in this problem. Okay, everything else is going to be less than 0. Okay, now remember, also we should memorize this, that the sine of theta is y over r. All right, so here's the best way to do this maybe. Okay, so remember, sine is y over r. The cosine is going to be x over r, right? And then the tangent of theta is y over x. Okay, so if we remember these three, then the rest of them are going to fall in. All right, so what this means is that y is equal to 12 because it's the numerator, and r is equal to 13. Right? To help us find x, we're going to use the relationship x squared plus y squared equals r squared. Right? And so that means that x squared plus 12 squared is going to be equal to 13 squared. If we solve, x squared plus 144 equals 169. We're going to subtract 144 from both sides, and x squared is 25. And by taking the square root of both sides, x is either plus or minus 5. All right, now remember that the cosine is going to be less than 0, right? We said that the only functions are going to be the sine and the cosecant function, all right? So that means that x must be equal to negative 5, okay? Or at the end of the problem, we just make this every function negative except for the sine as well as the tangent function, okay? So we know that the sine function is going to be 12/13. Inherently, that means the cosecant function is the reciprocal, which is going to be 13/12. We know that the cosine function is going to be x over r, so that's going to be negative 5 over r, which we said was 13. And it should follow that the secant function, which is the reciprocal of cosine, is negative 13 over 5. Finally, the tangent of theta is going to be negative at y over x. We know that y is 12. We know that x is negative 5, so it's going to be negative 12/5. Okay, and of course, it follows suit that the cotangent function is going to be negative 5/12. All right, so those are our 6 trig functions. Okay, and again, it follows that in quadrant number 2, the sine function is positive, but every other function is going to be negative except the cosecant function. Another example of this, that the cotangent function is 3/4, where theta is between 180 and 270. All right, so what does that mean? Well, if we were to draw an angle, okay, we know that this is 180 degrees, and we know that, so we have this angle would be 180, and this angle would be 270 if we were to draw it. And so that means that we should end up in quadrant number 3, which means that both x and y are less than 0 in quadrant 3. All right, so that means that, remember, the cotangent function, right? So our cotangent of theta, which is x over y, okay, by definition, should be negative 3 over negative 4, okay? And that helps us because, remember, when it simplifies, that goes to positive 3/4, okay? But we should also find r, so we're going to use, remember, it's x squared plus y squared equals r squared. Negative 3 squared plus negative 4 squared equals r squared. 9 plus 16 equals r squared. 25 equals r squared, and technically plus minus 5 equals r, but remember that r is greater than 0. Okay, so that means that r is going to be equal to 5. Okay, so we have our three values that we need, -3, -4, and then 5. Sine is going to be y over r. And remember, we said that y was going to be -4. Okay, so that's going to be -4/5. That means that the cosecant function, which is the reciprocal of sine, is going to be -5/4. And then the cosine function is x over r. And remember, we found that x was -3. All right, so that's going to be -3/5. And that also means that the secant function is going to be the reciprocal, which is -5/3. We already knew the cotangent function. Remember, the cotangent was 3/4 from initial. That means that the tangent function, which is y over x, technically would be -4 over -3, which just turns into 4/3, all right, which is certainly the reciprocal of 3/4. Okay, so that's how we can work with our signs of our trigonometric functions. Okay, so again, just remember that saying, all students take calculus, okay, and you just draw the letter C as in calculus to maybe help you remember. Okay, so, and remember, all of them are positive in quadrant one. All right, so our next videos, we're going to take a little bit further look with our trigonometric functions and signs. And then we're going to finish up our section by looking at some of the other sorts of trigonometric sort of ideas that regard with the signs of trigonometric functions.